Welcome to the mathematics in my channel. Today we are going to solve another interesting question. The question is, what is the sum of red area? What is the sum of red area? So we should find the red areas by using calculus. Okay, first I draw the picture. So we know this distance is 2, so this is 1 and this distance is equal to 1. So we can write these equations because we know this is the origin. I got the origin as center of the circle, so this is 0, 0 point, and we know this distance is equal to 2. So here I got this point P is equal to 0, 2, and I'm going to take this point Q. So first we can write the equation of the circle. So we know x square plus y square is equal to we know radius is equal to 2, so here 4. Now I'm going to isolate the x, so x is equal to square root of 4 minus y square, and I'm going to take this is equal to f of y is equal to square root of 4 minus y square. Okay, then we should find the q. So we know in this point the y is equal 1, so if we plug in here y is equal 1, so x square is equal to 3, so x is equal to plus or minus square root of 3, but here this is positive side, so we know x is equal to square root of 3, so we can write this is square root of 3 comma 1, and we know also this point the square root of 3 comma minus 1. Okay, then we can find the line equation of PQ. So PQ equation we can write y minus 2 is equal to gradient, we know 2 minus 1 over 0 minus square root of 3, here x minus 0. So y minus 2 is equal to minus 1 over square root of 3 times x. Now we can isolate the x. X is equal to square root of 3 times 2 minus y, and I am going to take g of y is equal to square root of 3 times 2 minus y. Okay, then now we can find the areas. So I am going to take this region, area of A, so we can write A, area of A region is equal to absolute value of now we can take the area under the curve by integration. So integration for y is equal 1 to y is equal 1 to 2, y is equal 1 to 2, the circle equation f of y, so f of y minus g of y dy. Okay, now we can plug in here absolute value, and here integration from 1 to 2, f of y is equal to square root of 4 minus y square minus g of y is equal to square root of 3 times 2 minus y here dy. Okay, then we should integrate integration of square root of 4 minus y square. So I am going to evaluate this integral in other place. So we take 4 minus x square dx. Now we can take the here 4 minus y square dy. Now we can use substitution method. So if we take y is equal to 2 times sine of theta, dy is equal to 2 times cosine of theta d theta. Okay, then we can plug in here. Now 4 minus y square, we know 4 times sine square of theta, so we can take 4 as a common factor. Now here inside of the square root sign we will have 1 minus sine square of theta, so we know cosine square of theta, cosine square of theta dy is equal to 2 times, sorry, here for the we think this 2 including this 2, here 4, so here cosine of theta d theta, so we will have 4 times integration of cosine square of theta d theta. Now we know cosine square of theta is equal to 1 plus cosine of 2 theta over 2, so 2 get cancelled, and here 2 times 1 plus cosine of 2 theta d theta, and we know this is equal to 2 times here theta plus sine of 2 theta over 2. Now here we know theta is equal to inverse sine of y over 2. So we should plug inverse sine y over 2 for theta. Okay, then here we can write now absolute value. Now we know here 2 times theta is equal to inverse sine y over 2 plus here we have sine of 2 theta over 2, but if we multiply by 2 get cancelled, so sine of 2 theta we know this is equal to sine of 2 times inverse sine of y over 2 minus square root of 3. We can integrate this 2 times y minus y square over 2 from 1 to 2, here absolute value sign, and now we can plug in values. So if we plug in 2, we know 2 1, so inverse sine of 1 we know pi over 2, so 2 times pi over 2, and here if we plug in 2 inverse sine of 1, here inverse sine of 1, inverse sine of 1 we know pi over 2, but here 2, so 2 get cancelled, so sine of pi we know 0. Then here if we plug in 2, here minus sign, 2 times 2 4, here 2 square, so 4 square over 2, 4 over 2 we know 2, and here 2, so 2 times the square root of 3. Then we should substitute 1, so here inverse sine of 1 over 2, so we know pi over 6, so 2 times pi over 6, then here if we plug in 1, here 2 times inverse sine of 1/2, so 5 over 6, here 2, so pi over 3, so we know the square root of 3 over 2 minus, if we plug in 1, here 3 times the square root of 3 over 2. Okay, now we can simplify, here 2 get cancelled, and pi here 3, So we know this is equal to 2 pi over 3 minus 2 times the square root of 3. So yeah, if we simplify, this is equal to minus square root of 3, and we know 2 pi over 3 greater than the square root of 3. So a of a is equal to 2 pi over 3 minus the square root of 3. Okay, then we should find this area, area of B. So we can write area of B is equal to absolute value of, now we know minus 1 to 1 f of y minus g of y dy. Okay, now we know this is same integral, so we know the answer is without substitution limit, we know this is equal to 2 times inverse sine of y over 2 plus sine of 2 times inverse sine of y over 2 minus square root of 3 times 2y minus y square over 2 from minus 1 to 1. Okay, now we can substitute upper limit and lower limit. So if we plug in 1 here, inverse sine 1/2, so we know here pi over 3 inverse sine of 1/2 pi over 2 to so here we have square root of 3 over 2 minus 3 times square root of 3 over 2 minus, now we are going to plug in minus 1, so minus 2 times pi over 6 minus square root of 3 over 2 plus 5 times square root of 3 over 2. Okay, now we can simplify here including 5 only these terms. So if we simplify, we know 2 pi over 3 here so here 3 times square root of 3, and we know 3 times square root of 3 is greater than 2 pi over 3, so the area is 3 times square root of 3 minus 2 pi over 3. Okay, then the red area is equal to area of A plus area of B. Area of A here 2 pi over 3 minus square root of 3 plus 3 times square root of 3 minus 2 pi over 3. 2 pi over 3 get cancelled, and here we have 2 times the square root of 3. Okay, this is the answer. If you like this video, please subscribe this channel. Thank you for watching.